how are the exams going? I have, yeah, so how are the exams going? How did the marks come? And everything good? Everything okay? Because ultimately everything so comes up to this one thing, which is the marks, right? My funda is that one day exam cannot decide how much you have prepared for the entire time, but yeah, that is the only criteria, unfortunately. That, that mark sheet. Okay, so yeah, how did the exams go, guys?
They went good, sir.
It went good. And did you guys get the marks? Yes, yes.
Not yet, sir, but my exams are coming again.
Oh, again, when is your exam? Good.
Yes, sir, 19th.
19th. And what are the topics?
Sir, actually, we didn't got the portion paper yet, but they told that the exams will be starting from 19th.
19th.
Yes,
Phase
sir.
one, right? So they should tell you beforehand. And that would be obviously the next set of chapters.
Yes,
Earlier,
sir.
yeah, earlier you had what? You had AP, triangle, something like that. Probability, yeah, like, so what was those chapters? What were those chapters? Abhi, what about you? Any exams which are happening?
Sir, I'm gonna have models out of 80, but it will be in December.
Oh, in December you have lost some
So we
time,
have time,
right?
yes.
Yes. So yeah, we should not relax because winter is coming, right? December is coming. So, yeah, start preparing, right? Start preparing
Yes,
that
sir.
we should not, yeah, we should not leave any stones unturned, right? Yeah. Nowadays, every uh, okay, so yeah, we should not relax and start preparing for it. Okay, and yeah, so you guys have these scholarships, right? When you top your school, when you top your, so you have these scholarships, and those are very good. Try to achieve that, okay? Because nobody told me in my younger days, nobody told me to just stop your school so that you get scholarship. Yeah, we can lighten up the burden of our parents and all the other things. So these things we can, okay, at least we can try. Right, guys?
Yes, sir.
Yes, sir.
So where is the she's still not here. So you guys didn't try this 13th one. Let us quickly do this. And what is next? So I just did this problem a moment ago, but I will also explain this. What are you guys planning after your 10th standard? What are you guys planning?
Assalamualaikum, sir.
Walaikum salam, walaikum salam. Your friends were just with him. So you got late. You got late again. What is happening? And have you started practicing? When is your next exam, Amira?
Sir, my PhD would be like in November.
November 18th,
No, sir, not on 18th. They'll start at 20.
20. Yeah, so you start preparing. Whatever. Do you have this syllabus? What are the what are the chapters? What is the syllabus? Please,
Yes, sir, we got.
Yeah, so tell me the syllabus beforehand and start preparing, and whatever the questions doubt, please do it. Okay. So this 13th question we have to find the cost of making the design at the rate of 0.35 per centimeter square. So what is this centimeter square? Centimeter square is length or area?
Area, sir.
Area, right? So this design has some area, right? And we have to find out that what is the cost of making this design, right? So we know that this is given as for 1 centimeter square. The cost is 0.35 rupees. So then we have to find out the total area of the design, and the total cost would be area into the per centimeter cost. Right, so this is the total cost. So this is the code, right, guys? And to find the total cost, we have to find this area. So this is the 13th question. And what is this shape? Amira, what is this shape? What is this geometrical shape? What is this? So long, whatever shape. Yeah, what is the shape? Whatever, so
A
long,
segment.
sec, right? Absolutely right. So this is a segment, right? And to calculate the area of segment, we require a sector, right? And we remove the triangle from this sector. Then we will get the segment. So this total is design is 1, 2, 3, 4, 5, 6 segments. So this area, which is the design, is 6 segments, right? So then we have to find out the segments, and segment is what? Segment is sector minus triangle. So we have to find out the area of sector and area of triangle. So to find out the area of sector, the radius is already given, that is 28. So we have to find out this angle. So how can we find out this angle? So we just make these designs, right? So we have how many angles? 1, 2, 3, 4, 5, 6 angles. So 6x is total angle is 360. So x is 360 by 6, which is 60. So now we have this angle also. So area of a sector would be how much? That would be theta by 360 and then pi r square. So theta, which is 60 by 360, 22 by 7, r is 28. So this is 6, and this is 4, this is 2, this is 3. So this is how much? 44 into 28 by 2. So this is area of sector. And then we have area of triangle. Area of triangle is what? So this is the triangle that we have. 60 degree, and this is 28, 28. So half A and B So half AB sine theta. This is 40 and 28 and by 2. So this is 7. So 7 into 28 root 3. So this is the area of triangle, and then we have to find out the area of segment. So step by step calculation, sector minus triangle. So sector is 44, 28 by 3. This is 7, 28 3. So 28 is common. And this is 44 by 3 minus of 7 by. So this will be 28 and 44 minus 21 root 3 divided by 3. So this is the segment. And then we have to find out the design. So area which is design. So design is what? Design is 6 segments. So that is 6 into 28, 44, 21, 3 divided by 3. So this cancels. And we have 56, 44 minus 20, and they have said to take this 1.7. So this would be 56, 44 minus 17 was the 17, 17 to the 34, and 135. So this is 56 into 0.0, so 3, and this is 13 minus 5, so 8, and then we have this 3, 3, 0, right? So 8 point, this is the design. Then total cost would be how much? So 0.35 into design. 0.35, 56, 8 point, how much is that? Now I cannot calculate further, right? So 0.35, 56, 8.3, so 162.60, and so this is the cost. Okay, so this would be the answer, guys. Any doubt? What did we do? So to calculate the cost, we needed this area. So to calculate this area, we know that there are 1, 2, 3, 4, 5, 6 segments. So this design is made up of 6 segments. Then we found out this segment, one segment, and that was sector minus triangle. So to calculate the sector, we calculated the angle. So we calculated the angle, then we calculated sector, triangle, found out the segment, multiplied by 6 to find the design, and then multiplied by this per cost to calculate the total cost. This was the question. Any doubts, guys?
No, sir.
Okay, so
Yes, sir.
you guys please note it down. In the meanwhile, I will have some one. So you guys quickly note it down. And then we will talk about the next chapter. Okay. Yes, guys, if you need me to scroll down the screen, please.
So can you scroll it down? Noted, sir.
Noted. Yes, what about you guys? Tejasvi and Nabila, what about you guys?
Done, sir.
Then,
Alright, sir.
noted. Good. Now, yeah, so as I was talking about, and one more thing. So in the previous class, I used the value of pi to 3.1. So I used the value of pi 3.14 and I got the answer 161.8. So that is also correct. And when I have used this pi to be 22 by 7, so I got 162.168. So both the orders are similar. So 1.82 and this is both are nearly 162 or yeah. So both are nearly 160. So both the answers are correct, right? So if you use the other values and you are getting this much, so don't be hopeless. This answer is also correct. But let's say you are getting an answer which is 159, 155, and something like 1768 and something like that. Then this is correct. So these are quite close. So then these two are correct. Okay. Yeah, so this was one point, and these are the things that we have learned in this chapter. So we have learned about the length of an arc, right? A part of a circle. Then we have learned about this sector, and then we have learned about this segment, which is when we remove this triangle from this total sector. So this is the thing that we get, and this is the segment. So these are the things that we have studied in past many classes, right? Okay, so the last question, the most difficult question of this chapter. What is the correct option, guys? Yes. All three of you, please tell me what is the correct option.
P by 720 into 2 pi r square.
So Abir is getting option B. What about you guys? Tennessee and
Same, sir. Option D.
oh, same. What about you, Amina? What is your answer? Yes, Amina.
Sir, option D.
Option D.
Yes, sir.
Option so same, right? Okay, good everyone. So this two is misleading, right? If we divide this two, so this would be 360
360.
pi r square. So that is the formula, right? Theta by 360 into pi r square. So that is the area of sector. Good. So this two is just to mislead you guys, but you guys are smart. So yeah, these small misleading things cannot deviate, right? Good. So now, as I've started this chapter in the first batch, so let's start in here, and I only talked about some things. So I cannot do it, right? Yeah. So in the previous set of chapters, area related to circle, we were talking about the areas of the objects which have only how many how many lengths? Yeah. Previous set of chapters, right? So let us take an example of a circle. When we are calculating area of circle, when we are calculating the area of a rectangle, when we are calculating the area of a square, area of a quadrilateral. So all these things have one thing in common, right? And what is that thing? Yes,
They are two-dimensional.
yeah, absolutely right. So they are two dimensional. They require length and breadth to represent it, right? So they require length and breadth to represent those geometrical shapes, right? So let's say if we are talking about, yeah, so dimensional objects. So we have this rectangle. So this rectangle requires this length and this width. And then we have this square. So this square requires again this length and this width. But this is equal. Again, we have this triangle, so this requires this length and this breadth, right? So let's see this is length, this is breadth. We have this circle, so again, this is the length and this is the breadth. So all these surfaces or all these geometrical figures require two things to represent them, right? So they require length, which means that how much we have moved in the x-axis, and they require breadth, which means how much we have moved in the y-axis, right? So these are called the two-dimensional objects. Whenever we require two things, or let's say two lengths, to represent the geometrical shape, so those are called the two-dimensional objects, right? And let's say we have, and then if we have these two-dimensional objects, then we talk about the length, and then we talk about the areas, right? So this is the perimeter, which is called the length. Again, the perimeter, again the perimeter, circumference. So all these two-dimensional objects will have some length, and then they will all have some area, right? So they have these two peculiar qualities. Let's say if we have a one-dimensional object which requires only one length, right? So let's suppose a wire, or let's say a line, right? So you have a line, and do you calculate an area of a line,
No.
right? So whenever you only require one thing to represent this geometrical shape, so that is called the one-dimensional object. So you only require length of this object, right? So you only calculate that. Okay. And similarly, let's say I was giving this example in the first batch. So you are sitting in a room, right? So just look at the corner of your room, right, and the bottom of the corner. So you will see that there are three lines passing through that point of the corner, right? Point which is at the bottom of the corner. So one is connecting the walls, right? So one is at the floor, right? And then what the third one is this the height, right? So you have a room. In your room, you have the floor, you have the ceiling, and then you have these four walls, right? So to represent a room, you require what are the things that you require? Yeah, to represent a room. Just look at the corner of the room. What are the things that you require?
Height,
Height,
height, length,
then
Length.
breadth.
breadth, right? So you require, let's say you have this floor, right? So at the corner of the room, you have one length and breadth of the floor. So, so this floor is of rectangular shape, right? Your floor is rectangular shape. So your floor requires the length and the breadth. But to represent the wall, you require additional thing which is the height, right? So one wall will carry one height and one length, right? Or let's say the adjacent wall will require one breadth and one height, right? So your room is made up of how many surfaces? How many surfaces are there in your room?
Six.
Six, right? So you have four walls and you have one floor and then you have this ceiling. So you have six surfaces, right? Right, guys? And you require three lengths to represent the, and that is length, breadth, and height. So those kind of geometrical shapes are called 3D objects, right? So generally, in a general case, in our daily life, we see 3D objects, not the 2D objects, right? So generally, we see three-dimensional objects in our daily life. So those are some general special geometrical objects are cuboid, which is your room, and then you have this cube, and then you have this sphere, and then you have this cylinder, and then you have this cone. So these are the general geometrical 3D objects and shape that you encounter, right? And now let us one by one talk about the surfaces of each. So let us talk about the surface area and volumes of these objects. So let's say first take this cuboid, right? So this cuboid again take the example of your room. So your room has the floor, plus you have this ceiling, plus you have these four walls, right? So what is this is, so there are six surfaces as Amira mentioned, right? So there are six surfaces. This floor is made up of which dimension? Yes, guys. So when you are counting,
2 dimension.
yeah, that is two dimension. And what are the parameters that you are taking? You have these three parameters: length, breadth, and height. So when you are counting the floor, what is the parameter that you are not counting?
Height.
Height. You are not counting the height, right? So in case of the floor, the rectangle which is it is made up of, that is length and that is breadth, right? So look at the corner. One line will show you the length, and the other line, adjacent line, other rectangular line will show you the breadth, right? So the dimension of floor is length to breadth. This is the area of the floor. Similarly, let's say that you go to the ceiling, right? Then again, what are the dimensions of the ceiling? What is the parameter that you're not counting?
Height.
Height.
Again, height. Yes, absolutely right. So again, you are not counting the height. You again are counting the length and breadth. So again, the ceiling will have length and breadth. Now, in four walls, there are two walls which are front and back, right? So two walls, front and back, and then two walls which are right and left, right? So in all these walls, what is the parameter which is always up? What is the parameter that you are always checking? Yes,
Height.
height. So Amira is saying height. Is that correct? Yes. Is that correct, everyone?
Yes, sir.
Is that okay with you, Tejasvi?
Yes, sir.
So we are counting the height is always there, right? And let's say if we take right and left wall, so that will contain length. And let's say if you take front and back wall, right, that will contain this breadth. So then this would be LB plus LB. So this would be the total surface area, and that would be LB plus LB plus 2LH plus 2BH. So this is 2LB plus 2LH plus 2BH. And in common, yeah, in conventional term, we write it like this is the total surface area, right? And if we somehow some cyclone is there, right? So your roof is gone. So then what would be the surface area without the ceiling? Yes, guys, what would be the surface area?
Sir, the four walls plus the floor. Surface
Right.
area of the four walls plus the floor.
So LB plus 2LH plus 2H, right? So LB and let's say 2H is common L plus. So this is the surface area without C. Why? And then somehow you remove the floor also. So without floor and C. So then you have only four walls, right? Which are 2pH plus 2LH. So you can take 2H common and plus 3 or 2 plus. So this is the surface area. Okay. And let me show you guys the example of this cuboidal box also. So you have this bottom, which I was calling the floor, right? So this floor is rectangular, and this is the length, and this is the breadth of this floor, right? So this is the bottom, so length, and breadth, and again top. So again it has this breadth and this depth. So these are the heights. These are the heights that we have. All these are heights, right? So if we are considering only the bottom part, so we have this length and we have this breadth. So LB. Again, we are considering this top part, so we have this breadth and this length. So LB. And then let's take this front part, right? So this was what? What was this that I told you?
Length.
Length, right? So this
Length.
is length and this is
Height.
height. So length and height, and back is again length and height. So length and breadth. Again, this is right part. So this was the breadth, right? And again, this is the depth. So breadth into height and breadth into depth. So you have these six surfaces, and I will not tear up this part because this is needed. So when I remove this part, so LP is gone. And when I remove this part, LP is gone. Then you have these four walls, right? So with the help of this box, we can also understand. Okay, so this was about this cuboid, right? And the only, yeah. So then you have this volume also, right? So in one go, I will also talk about this volume. So volume of cuboid. What does this volume tell us about, right? We saw that this surface area talks about the outer region that it is covering, right? So you have a three-dimensional object, and whatever the outer region, the outer region it is covering, that is called the surface, right? So, and this volume is telling us about the capacity of that cover, right? So, how much material, right? So, how many things that we can put inside this box? So that will be told us. That will be told by this volume, right? So the volume tells us about the capacity of the three-dimensional object. So it tells us about the capacity of the object, right? So how much things we can put inside the box. So that is given by length into breadth into height. So that is the volume. And what would be the unit of this volume? What would be the unit? So length is meter, breadth
Meter
is
cube.
meter cube, right? So whenever we see meter cube, so we just understand that that is the volume which is cube, right? Whenever we see meter square, so that is area which is given. Whenever we see meter, so that is length which is given, right? This is also a way to identify what is the physical thing that we're talking about. Okay, so this was about cuboid. And when we simplify things more, because nature has given so many of things which are simplified, right? So in nature, mostly what kind of shapes you could see that? what is the shape that you generally see? Most common shape. You have these five shapes. What is the most common shape of
Cuboid.
this one, right? Sphere.
Sphere, yes.
So from planets to, let's say, sun, whatever, cricket balls, volleyballs, or whatever, all these things are made up of these spheres, right? So they are spherical shape. And yeah. Okay, so second, first, but before we talk about this thing, let us talk about the second object. So simplified version of cuboid is cube, right? So if we take the dimension of cuboid as same, so if we take a cuboid whose length is equal to breadth is equal to height, let's say that is A, right? So that thing is called a cube. Okay, so oh, I didn't make a shape of this cuboid, right? Yeah, I should have made this. So I just gave the example, but I didn't make the shape, right? This is the cuboid. So this is the length, this is the breadth, and this is the height, right? Guys? Because I cannot make a three-dimensional object because the surface is two-dimensional, right? So this board is two-dimensional, so I cannot make a 3D object, right? But you guys just understand that this is the height, this is the length, and this is the breadth. So this is the floor, right? This is the ceiling, these are the walls. Okay, yeah. So now let us talk about the cuboid. So when we take all the length, breadth, and height equal, so that is called the cube. So just take the example of dice, right? So we have just understood in the probability that we have this dice. So these dice are in the shape of a cube, right? And then you have these sugar cubes also. So all these are three-dimensional objects which are of a cubical shape. So in cubes, all these are same. Length, breadth, and height are same. So again, we'll have six surfaces, right? And all these surfaces will have this dimension, A and A. Earlier we had uh, earlier we had LB, we had LH, we had PH, but now all will have AA. So then total surface area would be how much, guys?
4a square.
4A square. So only walls you are counting.
6A square.
Yes,
6A square.
6a square.
6A square, right? So you have these, so floors, are the floors and ceiling intact, base?
Yes, sir.
Okay, so then that would be 6A square, right? We can see from here also that we have A square, A into A into A into A. So 3A square into 2, 6A square, right? So 6 surfaces. And now let's say we remove the ceiling, right? Then that would be 5A square because 1A square is gone. So it is open from above, right? And then we remove the floor also. So that would be only 4 walls. So that is 4A square. Okay, quickly you guys note it down and then we'll talk about the sphere. So in NCERT, did you guys, so have you guys learned this before? So you guys have done this before, right?
Yes, sir.
Oh, this was already there because I am seeing the chapter and they just directly talk about the mixed shapes. So they have just combined these shapes together. But I thought that I should revise the portion, right? Yeah, whenever you guys want me to scroll down, please
Second,
tell.
sir, can you please scroll down?
Here I am talking about the right. In the next class, I will also talk about all these different shapes, so sphere, hemisphere, then cylinder, cone, and then we'll see the combination of these geometrical shapes.
Sir, can you please scroll down?
Yes, noted, guys.
Done, sir.
Done.
Noted, sir.
Again, so
Noted, sir.
you guys have these class assessments, so please take that test. And if you face any problem, Tejasvi, then please just send message to the Learnivio, right? The WhatsApp account.
Okay, sir.
So bye guys, and see you guys on Sunday. Okay.
Allah Hafiz, sir.